Well, to solve this question, let us first focus ourselves on these three compounds. Let us first write down the chemical formula of the first compound, this one. It would be, see, there are 1, 2, 3, 4, 4 nitrogen atoms. Here we have a carbon atom, so one carbon atom and two hydrogen atoms. Now come on to the next one. Here we have 4 nitrogen atoms, one carbon atom, two hydrogen atoms. So we find that both the first and second one have the same chemical formula. Now the third one. How many nitrogen atoms are there? 1, 2, 3, 4. Well, here we have a carbon and two hydrogens. So you see, all the three compounds have the same chemical formula. Now let's take up these compounds one by one and try to draw the resonating structures if they at all have. Starting with the first one, let us draw very minutely the diagram. Let me draw a carbon over here. Right. So we see that all the four nitrogen atoms have formed 3 bonds in all these cases. Now we also find that this nitrogen atom has a scoop to resonance by donating its or by involving its lone pair, which is in conjugation with this pi bond and also with this pi bond. I'm sorry, not with this pi bond, with this pi bond. So let's first draw it. Now let's draw the resonating figure over here. It's also called the canonical form. Remember a fact about resonating structures, that the overall charge of the resonating structures must be same. Okay, right. I think so. Now this comes over here, so it will have a plus charge, and since this pi bond has migrated to this nitrogen atom, so it will have a minus charge over here. So initially the molecule was neutral, and after the resonance, see, it is again neutral. Why? Here we have one plus charge and one minus charge, so overall it's once again neutral. Now you see, this is compound number 1. Does this compound match with any other compounds given over here? No. Now let us come to compound number 2. Let's draw that. Well, in this case, the resonance is possible. Well, this is a lone pair over nitrogen, which is in conjugation with this pi bond and also with this pi bond. So let's draw both of them. First, this one. Here we'll have a plus charge. This lone pair has been lost, and a minus charge because this pi bond now migrates over carbon. Now let's do the other option that is possible over here. That means if it migrates over here, then this will happen. So another resonating structure, let me draw over here. Well, this double bond will be there in this case. Now once again, so a new double bond comes over here, minus charge, plus charge. So this compound, which is compound number 2, shows two or gives two resonating structures which do not match with either of 1 or 3. Now number 3 compound has got no chance for resonance. Okay, so now let us take each of these options that are given. Take option number A. It says 1, 2 and 3 are resonating structures, which is absolutely wrong, so we can eliminate this option at first. Number B says 1 and 2 are resonating structures, whereas 3 is an isomer of 1 and 2. Is that correct? No. Number C, 1 and 3 are resonating structures, whereas 2 is an isomer of 1 and 3. Is that true? No. So that also goes out of the equation. So the last one could be our option. But before we tick it, let's see what it says. It says 1, 2 and 3 are constitutional isomers. We have already seen that these 3 compounds share the same chemical formula. That means CN4CH2. But are they constitutional isomers? Let's check that. Before that, let's see or let's discuss what is meant by constitutional isomers. Well, isomerism may be broadly classified into 2 categories. Number 1 is structural isomerism. Number 2, stereoisomerism. Structural isomerism deals with configuration. Configuration means, say for example, I am holding this magnetic pen in my right hand and this ink pen in my left hand. So this is a configuration. And stereo isomerism talks about conformation. Now what is conformation? Say I'm holding these 2 pens as I mentioned before, but I'm just changing their positions, but I'm not changing I'm not picking up anything else, or I'm not dropping these pens or swapping them. So conformation means the spatial arrangement, but structural isomerism, which deals with configuration means the bonding, atomic bonding, or the positioning of a particular atom or a functional group or a double bond or a triple bond, right? So these 3 compounds, we find that although they have the same chemical formula, but the positioning of double bond and the positioning or attachment of hydrogen atoms in each case, it differs from one to the other. So definitely it is a classic example of structural isomerism. So answer D, option D is our correct answer.